let's talk about factoring quadratics where a is not 1. So quadratic looks like ax squared plus bx plus c, and we're looking at specifically those where there is actually a number being multiplied by the x squared. It makes for somewhat more complicated factoring than if it's just x squared. So there are several methods you can use for this. So the first method, and these aren't in any particular order, they all work. Some work better in different contexts, but you can just guess and check. So especially if A or C, or especially if both of them are prime, or if they're both perfect squares, then guess and check can be a fairly efficient method. So if a is prime, then you know that ax squared has to come from ax times x. And so then you look at the factor pairs of c. There's two possible orders as far as which factor goes with the ax versus the x. So you have to test each of those, and the way you test is you're looking at the outside and inside multiplication. So you're checking whether those add up to bx. If c is prime, you wouldn't know what would go with the x, but you would know that it has to be c and 1 for the other part, and then you would guess and check for the coefficients of x in each factor. If a and c are both perfect squares, then you can guess that whatever they're the square of, that's the coefficient, and that there are two identical factors then. And then test again, you still have to check that the middle term comes out right. If not, then you might need to use other methods. Method 2, the AC method, this is pretty much the standard way to do this. It's a systematic approach. There's not as much guessing and checking involved. But the process is you multiply A and C, you get that product. Then you kind of do the standard factoring procedure. You're looking for a product, a factor pair for AC now that adds up to B. Once you get that factor pair that works, though, you don't just put those into the factor. You use those to rewrite BX as two separate pieces. So you're kind of reverse engineering the FOIL process. So if you started with the factors, you do the FOIL, you have the outside and inside terms that add up together to get BX. So we're kind of taking from the final form and backing up a step and saying, all right, what was the outside and inside terms that added up to get this middle term? And then we can factor. So you then have 4 terms and you factor by grouping to finish that. The order that you write those 2 terms that add up to get BX doesn't matter. It'll work either way. You do need to include the sign. So if C is negative, or even if A is negative, include those and apply the sign rules. I will say though, if A is negative, what I would do is factor out a -1 and just switch the sign on everything so that you don't have that additional complication. The third method that you can use is the swing method. So it has similarities to the AC method. It's a little less clear what's actually happening and why it works, but you have ax squared plus bx plus c. You kind of swing a over and multiply it by c. And so you now have actually a different quadratic that you're going to factor. You're going to factor x squared plus bx plus ac. Once you've factored that, then to swing back the a, so to speak, you're going to divide the r and the s each by a. And then here's where it gets kind of feels arbitrary, but basically if the division happens, you simplify whatever you can of that fraction essentially. So if it gets a whole number, you're done. That's the factor. If there's still a denominator and it hasn't fully simplified, then you would swing that denominator back over in front of the x for that factor. So I'll demonstrate all of these, not necessarily all 3 methods on every example, but the ones that would be essentially equally good to use. All right, so our first example here, we have 2x squared plus 5x plus 3. A and C are both prime, so this would be one where guess and check, again, could be reasonably efficient. We still have two things we have to test. So I'm going to start with, I know it's got to be 2x and x, and then it could be a 3, 1, or it could be a 1 and then 3. We do have positive, positive, so I know it's all going to be pluses, so that simplifies things a little bit also. But so I could have 2x plus 3 times x plus 1, or 2x plus 1 times x plus 3. And I figure out which one by looking at those outside and inside multiplications. So for 2x plus 3 times x plus 1, I get a 3x and a 2x. Those add up to 5x. So if that was my first guess, I got lucky. That was the correct one. If I had first tried the 2x plus 1 times x plus 3, I would get x for the inside and 6x for the outside. And like if one of those needed to be negative, that's the one that would work. So if it was a minus 5x instead of, if it was a minus 3 instead of a plus 3, then that would be the one that would be needed instead. But because they're all positive, they're being added together, then the 2x plus 3 times x plus 1 is the one that checks out. If you really just don't want to ever have to do the guess and check and have the wrong thing, we can use the AC method. So we take AC is 6. Look at factor pairs of 6. So 1 and 6 or 2 and 3. And again, because this is a positive 6, those would need to be both positive or both negative. And because that's a plus 5, both positive, I'm looking at what happens when I add those up. 2 plus 3 is 5. That's what I want. So I have the 2 and 3. I'm going to use that to rewrite. So I now have 2x squared plus 2x plus 3x plus 3. So I've split the 5x into the 2x plus 3x. And then I can factor by grouping. And I factor out a 2x from the first two terms, and I'm left with x plus 1. And I can factor a 3 from the last two terms, and I'm left with x plus 1. That's what you want to see, those identical factors. So now I can factor out the x plus 1 and have the 2x plus 3. All right, what if I wrote those, the 2x and the 3x in the other order? So I have 2x squared plus 3x plus 2x plus 3. Now when I look at the first two terms, all I can pull out of there is x, and I'm left with 2x plus 3. And if I look that I have the 2x plus 3, there's nothing in common there, but it's still helpful to then write that as plus 1 times 2x plus 3, because then you see those matching factors, the 2x plus 3, but you also see the terms of the other factor. So we have the 2x plus 3 times the x plus 1. So again, you wouldn't have to do both of those, just whichever one you happen to do should work. You don't have to make sure that you're doing it in the right order. That's the main thing there. And then to take a look at the swing method for this. So I'm going to swing the 2 over. So I have 2x squared plus 5x plus 3, swing the 2 over. So I'm going to actually now factor x squared plus 5x plus 6. So this is now the simpler kind of factoring where a is 1. The 6, again, is going to be the 2 and 3, x plus 2 and x plus 3 to multiply to get 6 and add to get 5. So we then need to swing back, and so we need to divide by the 2. So we multiplied by 2. Now we have to reverse that with division by 2. The 2 divided by 2 is going to simplify. The 3 divided by 2 isn't. So the 2 that's not going to simplify swings back. And so we get then our x plus 1 and 2x plus 3. The temptation may be, I'm just saying because I have made this mistake, to divide by the 3, because you think like the 2 swings over to the 3, and then when you're thinking of swinging back, like it feels like you grab the 3, but you're multiplied by the 2 and by a, and then you divide by a again as well. All right, so next example, 9x squared minus 6x plus 1. So here 9 isn't prime, 1 is prime, but 9 and 1 are both perfect squares. So this is still a good candidate for a guess and check, just to see at least maybe a 3x and a 3x for the 9x squared, 1 and 1 for the 1, and because it's a minus 6x, those will both need to be negative to multiply to get the plus 1. And then I just check the inside is negative 3x, outside is negative 3x. Those do in fact add up to negative 6x. So that's the factoring 3x minus 1 times another 3x minus 1, or 3x minus 1 squared. You could also use the AC method or the swing method on this. If you use the swing method, so you swing the 9 over, so you factor x squared minus 6x plus 9 and get x minus 3 times x minus 3. And then you divide each of those 3's by 9. So in this case, they partially simplify. So you then have x minus 1/3 times x minus 1/3, and you have a 3 that swings back on each factor to get the 3x minus 1. Next example, we have the same a and c, but here if you test the 3x, in this case it would be 3x plus 1, those middle terms aren't going to add up to 10. So rather than doing more guess and check with this, if I use one of those other methods, AC method, AC is 9. 9 is 1 times 9 or 3 times 3, but in this case, the 1 times 9 works because 1 plus 9 is 10. So I rewrite this as 9x squared plus x plus 9x plus 1, or as 9x squared plus 9x plus x plus 1. Either way, I can factor by grouping. So I can factor out an x in this first option from the first two terms and have a 9x plus 1, and then factor out a 1 to have the other 9x plus 1 and get the two factors of x plus 1 times 9x plus 1. With the other version, I factor out a 9x from the first two terms, leaving x plus 1, and then a 1 from the last two terms, and get the same two factors. Using the swing method, the 9 swings over. And so we're going to factor x squared plus 10x plus 9. And that comes out x plus 9 times x plus 1. And then divide each of those by the 9 again. The 9 divided by 9 is fully going to simplify to get x plus 1. The 1 over 9 doesn't simplify at all. The whole 9 swings back over to get the 9x plus 1. All right, and then final example here, 2x squared minus x minus 6. If you use guess and check on this, it's going to be 2x and x, but then it could be 1 and 6, 2, 3, 3, 2, 6, 1. So 4 possibilities, and then the negatives, because 1 will be negative and 1 will be positive. That complicates it a little bit more as well. So this is probably to the point where the guess and check method isn't necessarily going to be as efficient. So if I do the AC method, AC is going to be negative 12. So again, make sure you include the negative sign, so that'll keep in mind one of the factors needs to be positive and one negative. So 1 and 12, 2 and 6, 3 and 4. To get a negative 1, so larger factor negative, 3 and 4 will work then. So 3 and negative 4. So I rewrite this, and I'm only going to do one of the possibilities this time. Just at random, 2x squared plus 3x minus 4x minus 6. So the 3x minus 4x is what would have simplified to get the negative x. But I'm going to factor by grouping then. From the first two terms, I can factor out an x, leaving 2x plus 3. From the last two terms, I can factor out negative 2, leaving 2x plus 3. Those match, all good. The x and the minus 2 make up the other factor. So x minus 2 times 2x plus 3. For the swing method, if I swing the 2, I get x squared minus x minus 12. Factor that. And that would come out, and haven't been writing out listing factor pairs of 12 that add up to -1, similar to what you do with the AC method. So we have the -4 and the +3, and then we need to swing the 2 back. So divide each of those by 2. The 4 divided by 2 is going to work. That gives the x minus 2. The 3 divided by 2 doesn't simplify, so the 2 is going to swing back over in front of the x to get the 2x plus 3. So hopefully you can be confident with at least one of those methods to do factoring when a is not 1.